Hey guys, I am going to discuss today on Brachistochrone problem. So let us consider the given problem. So now in this problem, a particle slides under the gravity from the rest position along the smooth curve, joining the 2 points, that is a capital A and capital B, not in the same vertical line. Mean the particle move along the curve. So we need to find the curve in which the time taken from the point A to B is minimum. So now here, first of all, we will draw the diagram. So this is our required diagram. So you can see this is our final point. So let us suppose this point is that is x1 comma y1, that is the origin, and the particle is moving along this curve. So we need to find this curve, and further, and these 2 points A and B are not on the same vertical line. So let us take the point P on the curve, that is a P, and name is that is a x comma y. So distance of the point P from the x axis, that is a y, because this is a height of the point P from the base x axis and on the curve at a point P, and this is our arc length, that is a S. So now I am going to give the solution. Actually we are going to find the curve along which particle take the minimum time between A and B. So we will write here, let us suppose the point A 0 comma 0 and the point B, that is x1 comma y1, are the end point of the curve AB. So now let the particle, sorry, let the start sliding, particle starts sliding along the curve AB from the point, that is A, and this point is origin, that is 0 comma 0, and its initial velocity is 0. So after the time t, after time t, particle reaches at a point, that is a P, which is mentioned in the diagram, such that arc length AP This is arc length AP is equal to S. So by using law of conservation, law of conservation of energy, we have that is total energy at a point A has to be equal to total energy at B. And total energy means that is kinetic energy plus potential energy at a point A is equal to kinetic energy plus potential energy at a point B. But at a point A, because the particle is at rest, so at rest the total energy will be zero, and the kinetic energy will be that is half, having the mass m and the velocity of the particle that is v square, plus the potential mgh m, but here g that is a negative because acceleration due to gravity, and height of the curve from the x-axis that is a y. So we will write the height that is a y. So finally we can write here that is 0 is equal to half mv square negative m gy. So now from here half, that is half v square is equal to gy. So now further we can write here that is v square is equal to 2 gy, and the velocity v is equal to that is square root of 2 gy, and velocity that's the rate of change of distance ds over dt is equal to 2 gy. So finally we can write here dt is equal to ds over square root of 2 gy. So we can find the total energy taken by the particle from the point A to point B is. So this by taking the integration on both sides, total energy will be T, capital T, and this integration vary from 0 to x1, and ds over square root of 2 gy. And we know that the ds is equal to arc length, that is square root of 1 plus y dash whole square dx over root 2 gy. So we can write here 1 upon root 2 times of g vary from 0 to x1, that is square root of 1 plus y dash whole square over root y dx. So that is our, it become a functional, that is t of y of x is equal to this. So by comparing we will get the functional f of x comma y dash is equal to the square root of 1 plus y dash whole square over square root of y. And here our boundary condition, that is y of 0 is equal to 0 and y of x1 is equal to y1. But as we can see that f is independent of x. If f is independent of x, then we can say that del f over del x has to be 0. So by using Euler's differential equation, as we know that d over dx f negative y dash del f over del y dash negative del f over del x has to be 0. So from here d over dx, that is f negative y dash del f over del y dash negative 0 is equal to 0. So it implies f negative y dash del f over del y dash is equal to the constant c. Put all the value here. Our given functional f, that is the square root of 1 plus y dash whole square over root y negative y dash. So differentiate the f with respect to y dash. It will give multiply to 1 upon square root of y. Differentiate this function with respect to y dash. So it will give, that is 1 upon 2 times of square root of 1 plus y dash whole square multiplied to 2 times of y dash is equal to c. So further simplifying, it will give 2 to get cancelled out. Take the this term 1 upon root y, and here 1 upon root y as a common. So we will get 1 upon root y, take as a common, we will get square root of 1 plus y dash whole square negative y dash whole square over square root of 1 plus y dash whole square is equal to c. So now cross multiplication, we will get 1 over root y. After the cross multiplication, we will get, that is 1 plus y dash whole square negative y dash whole square over square root of 1 plus y dash whole square is equal to c. It implies 1 over root y. So as we can say, this term we can get cancel out. So further it can be written as 1 upon square root of 1 plus y dash whole square is equal to c. So now take the square on both sides. After squaring on both sides, we will get 1 upon y multiplied to 1 upon 1 plus y dash whole square is equal to c square. So further take the reciprocal on both sides. You will get y multiplied to 1 plus y dash whole square is equal to 1 upon, we can write here, So that is 1 upon c square. So further 1 plus y dash whole square is equal to 1 upon c square y. So further we can find the y dash in terms of y. Y dash whole square is equal to 1 upon c square y negative 1. So take the LCM on both sides. We will get y dash whole square is equal to 1 negative c square y over c square y. So now divide the numerator and denominator by c square. We will get 1 over c square negative y over that is a y. So degree of y that is a 1. Here degree is that is 1, and here also the degree that is the 1. So we can write as that is 1 upon c square is a constant. We can write here that is a negative y over y. Here 1 over c square is equal to a. So now further take the square root on both sides. That is y dash is equal to a square root of a negative y over y. So dy can be written as dy over dx is equal to square root of a negative y over y. So we can write here as a variable separable form, that is a root y dy over square root of a negative y is equal to dx. So now further this can be written as the whole square root y over a negative y dy is equal to dx. So now integrate on both sides. So that is a constant we can write here, that is the capital, let us suppose b. So now we need to substitute here, that is we can put here put that is y is equal to a sine square theta by 2. So now on differentiation we will get dy is equal to a multiplied to 2 sine theta by 2, and derivative of sine theta by 2 that is a cos theta by 2, and derivative of theta by 2 with respect to theta it will give 1 by 2 d theta. So this value is equal to dy, 2 get cancel out. So we can write here a sine theta by 2 cos theta by 2 d theta. Substitute the value in above integration. It will give integration of square root of y that is a sine square theta by 2 over a y that is a sine square theta by 2 and dy that is a sine theta by 2 cos theta by 2 d theta are the integration with respect to x. It will give x plus b. So further simplifying we can take, you can see here, if I take the a as a common from denominator, a will be get cancel out. So now further it will be reduced as sine square theta by 2 and 1 negative sine square theta by 2 a sine theta by 2 cos theta by 2 d theta is equal to x plus b. So it implies integration the square root of sin square theta by 2 over 1 negative sin square, that is a cos square theta by 2, a multiplied to sin theta by 2 cos theta by 2 d theta is equal to x plus capital B. So we can take the sin theta cos theta from the root as a common, that is sin theta by 2 over cos theta by 2, that is a sin theta by 2 cos theta by 2 d theta is equal to x plus B. This part get cancel out. Sorry, uh, here will be cos theta by 2 and cos theta by 2 get cancel out, and it will become that is a in the integration of sin square theta by 2 d theta is equal to x plus B. So finally this can be written as a 1 over 2 1 negative cos theta d theta x plus B. Here will be a by 2, that is integration of 1 negative cos theta d theta is equal to x plus B. Integration on both sides, on sorry left hand side we will get theta negative, integration of cos, that is a sin theta, is equal to x plus B. So now here, as we know that this formula is half angle formula, as we know that there is a 1 negative cos theta is equal to 2 sin square theta by 2. This is a half angle formula, and from here, as our initial condition, it gives by using y of 0 is equal to 0. That is, we know that y is equal to a sin square theta by 2. So we can see here value of y is 0. That is 0 is equal to a sin square theta by 2. So from here we will get theta by 2 has to be 0. It implies theta is equal to 0. If theta is equal to 0, so put here, we know that x is 0. As we know that x is equal to 0 and theta is equal to 0, put this value here. We will get a by 2. 0 negative sin 0 means 0, that is 0 plus B. So from here we will get value of constant B is equal to 0. So further putting this value in above, we will get value of x is equal to a by 2 theta negative sin theta, and a by 2 can be written as x is equal to capital A as a constant, theta negative sin theta, and this is a parametric form of the curve, and y can be written as a sin square theta by 2, that is a by 2 1 negative cos theta, and a by 2 can be written as, that is a as previous, capital A multiplied to 1 negative cos theta. So therefore the required extremal, or we can say curve, is that is x is equal to capital A in bracket theta negative sine theta, and y is equal to capital A 1 negative cos theta, and we can say it represent, actually it represent cycloid. So finally we can write the time taken by particle time taken by the particle is minimum along the curve cycloid. So finally we can write this is our required final answer. So now I am going to sketch, or I am going to show the path of cycloid online by using online tool. First of all, we need to consider the given cycloid, that is y is equal to capital A 1 negative cos theta, and value of x, that is a capital A theta negative sine theta. So now open the bracket by multiplying the A, it will give A negative A cos theta, and x equal to A theta negative A sine theta. So now consider, so this is our desmos. So from here you can see, so here this is our parametric form. Here the theta, in place of theta, here there is a parameter t, and this is our parameter here a. A is a constant. A t vary from 0 to 1, and after simplifying we will get the circle having a center a, and having a center that is a comma 1, and radius that is a 1. If I vary the value of a, you can see the how the you can see the path, you can see the path, this path is known as cycloid. So you can see how the particle move along the cycloid. If I vary the a, then you can see how the particle vary along the curve. So that the blue curve is known as cycloid, and the motion of the orange along the circle is a particle. So this green path is known as path of cycloid. So therefore we can say that this curve represent cycloid. So this is our required final answer.